Great evening, everybody, and it's amazing to see you physically here after the corona, after the fifth wave. So thank you, everybody, for coming today. It's really a pleasure to have Confluent first, right, Morad? First Confluent Wix together, a meetup. We're hosting here Tim. Hi, Tim, how are you?
Doing well, how are you?
We are great, thank you. It's good to having you here. I mean on the screen, but yeah, all come to see you here, but hopefully next time. I promise them there will be a compensation for that. Hopefully next time.
Yes.
Great, thank you, Tim. And also today, Natan we will hear him, and before we will start, I want to share with you something. I think this time of the year is really exciting time. We are just before the sailing season. Everybody in the world try to optimize to buy their merchandise in the Black Friday and the Christmas and everything. Of course, this is really happy time, except the sailing stuff. But one thing is, in Wix, this period is really, really interesting because, you know, we also manage shops, and this time of the year, we always want to be available and online. And I remember, even from Aviran, the VP Engineering, a war stories about, like, I think it was 2015, Wix, it's before the Black Friday, and everybody, like, a surprise, but a fear about what will happen. And we know that any spike in traffic, something that will happen, Wix is going to be down. And now, I think a couple years later, we took some actions. You will hear Natan and what action we took and what we did to help Wix grow exponentially and be a better place and much more resilient. And you will hear about that. So I hope you, by the way, how many people here use Wix or have a website on that? One? Okay. I hope in the online we'll get more. So yeah, Wix basically is a website building platform. Come to solve one thing, which is unsolving or creating simple flow to create your online presence. And basically, this is our mission. Any business or any people on earth to make their online dream come true. And it sounds like terrific and nice, but basically we are, I think we even more, 7% of the website in the world are hosted on top of Wix backend. I think last month I checked is 1.7 billion websites, and this is the number, and the number not growing linearly, just to understand the order of magnitude of the scale that we are facing. So nice to meet you all. I'm Avi. I'm part of Wix Engineering group. You probably hear, or if not, I really recommend you to hear about how our organization is structured in the guild and startups. And what is good is help Wix go healthy and make the goals that we want to create. And in the recent years, we did a major transformation from website building platform to the cloud for businesses. And what does it mean? It means that we are not only creating a website, we're managing online shops. We have a functionality for advanced booking, scheduling, even payment clearing. I think we pass billion of a lot of the money in the merchandise go through our payment mechanism. And this raised the challenges, the engineering that we face. We grew dramatically in all scales, like teams, more traffic that we serving, and even our global presence to being totally fully distributed. And the picture that you see here is not the Starship Enterprise, it's the microservices clusters. Each rectangle is a microservice cluster getting traffic in production. This is a map that I took couple of months ago from New Relic, just for you to understand the order of magnitude of microservices and to get a better context about what Natan is going to explain. And on top of that, we also manage our Kafka clusters in a fully distributed environment. The scale of Kafka is not linearly with the potential traffic, is with the new flows that we're creating. It's even growing with the traffic, but new flows that the developers creating, business use case that we want to solve. And that creates quite a big challenge, and we always try to see how we can engineering fix it properly and gain the velocity for the entire backend engineer and even the entire engineer. So enough me. Natan, please.
So thank you very much, Avi, and welcome everyone. My name is Natan Silnitsky, and I'm a backend infrastructure team lead at Wix.com. And this talk is about Wix's Kafka-based global data architecture and platform. So how we made it relatively simple for Wix's 2,000 microservices to be able to produce and consume data no matter where these services are deployed around the world, and also no matter on which technological stack they are built on. And I will also talk about how we created tools and services that enabled us to have high resilience in our distributed system. We saw the huge scale and increase exponential traffic that Wix has built. So we also talk about how we manage that successfully. So this story is a story of growth. We managed to have, in a simple fashion, helping our Wix developers as an infrastructure team to easily handle the exponential growth in our scale. And a few years ago, we partially migrated, and it keeps increasing, to event-driven architecture based on Kafka for our microservices communication. And we did that, and we see how this change, this working in such an architecture, really is much more optimal for dealing with increasing scale, for dealing with failures in your distributed system with all these services, much better than the way traditional request-reply architectures work. And not only that, we also have other scaling criteria to handle. We are deployed globally, but also we have hundreds upon hundreds of developers working on these services, and they have all kinds of use cases that need to get support. And they also work on diverse technological stacks. So we will see how we tackled that with our own messaging platform we built on top of Kafka called Greyhound. So we have a quick introduction on Kafka, then a quick introduction of Greyhound, and then the main part is how we tackled two important blockers in our goal to have a single global data mesh, scalable data mesh at Wix. So the first one was our single cluster in each data center really got overloaded, not much with the amount of traffic that kept increasing, but more with the amount of topic partitions. So we had hundreds of thousands of topic partitions that every day were increasing, and that meant that the self-healing of the Kafka cluster, when you have some broker going down and then you want you fixing it and you bring it back online, we want that to be fast. But if you had, at least at the moment with Kafka, so many topic partitions in the same cluster, then that process of self-healing can take a long time. I know that with removal of Zookeeper, that will be better. But anyway, we decided to move to a multi-cluster environment, and we'll see how we made that really simple and easy in our platform. And finally, the whole topic of cross-DC communication between microservices. We know that it gives a lot of complexity for our services that need to be decided on which data center they are deployed, where are the services that produce the events, and where are the services deployed that consume them, how do they interact, all of that. We really wanted to reduce this complexity for our developers and keep things as simple as possible to really create our own global, scalable data mesh. So we'll start off with a very quick intro for Kafka. I assume most of you know how Kafka is run and built, and if by any chance you need a quick refresher, so we have a Kafka broker, and events, messages are produced to specific topics, and these topics are divided into partitions. And what's interesting here is that the Kafka producer just produces new events to the end of the partition. The partition is, can think of it as a commit log, and basically a file where you just keep adding stuff at the end. And that means much better performance than traditional message queues. And also, Kafka consumers then have a pointer to where they're currently processing events from the partition. And unlike traditional message queues, they actually don't need to remove physically messages from the queue. They just scan, and once they finish processing one message, then they can commit it. And if there's restart or something like that, then they will they will start off from the first non-committed message. And of course, with Kafka, we're talking about scale. Really easy to scale this operation. You just add more partitions and more pods in Kubernetes for your services, and that's it. And of course, we're talking also about how this infrastructure helps us to be more fault tolerant. Well, Kafka clusters, of course, have data replication, and these partitions are actually replicated across multiple brokers. So that's also something that we can work with. Okay, so that was the quick intro for Kafka. Now let's see what kind of messaging platforms were built on top of Kafka in order to help us with the growing amount of use cases, developer services, tech stacks, etc. So actually, we decided a long time ago already, when we first started using Kafka, I think it was 2015, that we won't use the Kafka SDK directly. We will have a wrapper layer on top, and we called it Greyhound. And a year or so, 2 years already ago, we actually decided to open source Greyhound, and we'll see what actually we provided for our developers on top of what Kafka has to offer. So almost all 2,200 microservices at Wix use Greyhound for their event-driven programming. And if they use Scala, then it's really simple for them to create a Greyhound consumer. They just specify the consumer group name, the message handler, which is basically the lambda that they have the processing code there, and a topic name. And of course, for producers, then they just produce to specific topic, and that's the way the setup is done. It's really simple. Now, in terms of what feature Greyhound offers Wix developers and global community that's using our open source version, so we have parallel consumption. So you have your pods in Kubernetes, your instances, and you can choose the amount of parallelism that you want to have in the specific pod. So it's maybe handling, I don't know, 50 partitions, but you can play around with the amount of parallelism, the amount of fibers that are running your code. And batch consuming, very important in cases where you have bulk APIs. So it's really important that you actually handle these messages in batches, and then you can call other side effects with bulk API. Really improves performance. Then we talk about resiliency. Then we have consumer retry strategies, and here we can think about whether we allow for retries to be in order or out of order, but there are different flavors. But the most important thing here is that we have the distributed system with services running stuff all around the place, but we don't get immediate feedback like request reply. So it's really important that you get a successful completion of processing eventually, and that's what these strategies allow in services. Resilient producer, that's for cases where Kafka broker is currently unavailable to you, some networking issue maybe. So Greyhound just saves the events to disk, and then when network resumes, it can read the messages back, and that also works with Kubernetes. Even for pods that are flushed out, we have a mechanism for that as well. Context propagation, so that's another very critical key feature for us at Wix, as we have the user context request incoming from the browser, and we want to know everything we can about this user, and then the flow goes around all our services, and we also have experiments like A/B testing set up there. For all this context travels fluently, automatically, and seamlessly around all our services, so they can always access this information, the request context. Very important for well-functioning microservices ecosystem. And also matrix reporting. So of course Kafka provides matrix out of the box as well, but with Greyhound, what we do at Wix, we utilize it for higher level matrix, like for application levels. So if you want to know on average, or P99, how long does it take for your message handler, your actual processing code, how long does it take? Has it started to take longer and longer? And maybe you're starting to get lag alerts. So also with Greyhound, we have built-in lag alerts, consumer lag alerts, whenever there's a slow consumer. So all of this package really helps Wix with the event-driven infrastructure that we actually require in order to have a healthy, growing environment, production environment. Now, the original Greyhound library was built as a JVM library, so written in Scala. But we also wanted other growing parts of the services at Wix to also use it. So we created a Greyhound sidecar. Originally, the Node.js services at Wix had their own like mini version of Greyhound. Not all features were implemented there. And it was also a less good experience for running in Node. So we decided to create Greyhound as a service. So this service is running alongside the main application in the pod in separate containers. And it just, so it's really good performance. It doesn't impact performance. And more importantly, with using the power of protobuf, it's really easy for everyone at Wix, no matter on which technological stack they're building their code, to actually interact with the sidecars. So we also have data organization services consuming events from the business microservices via Greyhound sidecar, via the service. Also, our serverless functions utilize Greyhound service in a more complex setup. But everything is working with the same code base, the same engine of the Greyhound working in the JVM library. So we have freed everyone to work in their technological stack. And the fact that everyone is working with such a standard way of operating with event-driven design actually meant that all infrastructure had the power to do whatever they wanted on top of Greyhound. So other parts of Wix infrastructure created concepts of domain events. So whenever you update your database, you automatically send that your domain business object has changed, and the developer doesn't even need to set up Greyhound here. It just set up the domain event. Or extraction of business events to the data warehouse. That's all of the interactions of data developers is done without actually working in Greyhound, because that's done on a low level. Task scheduling is also performed with Greyhound so that you can schedule stuff you need to do in the future in your services. And asynchronous queues. So a lot of stuff have been built on top of one on top of the other here to really get the best features that can utilize the power of event-driven programming. Cool, so that was a quick introduction to Greyhound. Now let's talk about our problem that we had, a Wix with cluster overload. So of course, each Kafka cluster is usually worked on inside the data center, because once you want to produce to a Kafka cluster in a remote data center, you're probably going to have higher latencies. So we used to have a single cluster in each of our data centers, and they became overloaded, like I mentioned at the beginning. Many topic partitions. The success of Greyhound and the event-driven programming style meant that the cluster just became too big for us at Wix. And what we decided to do is simply to create more Kafka clusters in each of the data centers. And so we partitioned it. We need to think about, wait, how will we decide which topics go into which cluster? So the decision was that we're going to do it by the service level agreements. So we have a cluster dedicated for Wix site owners that edit their site and configure everything. And that's a different SLA than site visitors visiting our sites that, of course, need to have the highest percentage of availability possible. So we wanted to reduce the blast radius and each cluster impacting its own segment. And that's how we decided to segment it according to which user is interacting with our microservices environment. Now, when a Wix developer wants to utilize this multi-cluster environment, then if they use the Greyhound API directly, all they need to do is, with the same Greyhound consumer and producer, just specify .cluster A, .cluster B. This is the cluster that I want to consume this topic from. And in case that they're interacting with higher level constructs at Wix, usually it will be done in protobuf. They just specify, I want to consume something, and it's found on this cluster. Now, this actual part is not found on the open source version of Greyhound. It's actually only on Wix private layer of Greyhound, but we are thinking about how to also introduce multi-cluster support for the open source version as well. And you may think to yourself, wait, but how do I actually know if I want to consume a topic, on which cluster is it found? So here we just have our back office. It's called Greyhound Admin, and it's a service that every Wix developer is familiar with. And they go to topic configuration view, and they type the topic that they want to consume, and they can easily see which cluster this topic is found on. Okay, so we solved the cluster overloaded issue. And now I want to talk about DC awareness. So we're talking about globally deployed services, and we have our services deployed all around the world in multiple data centers. So we have situations where we have different data centers serving different purposes. So we have the master active database currently found on our, let's say, main DC, and another data center will serve as master passive, right? In case we want to be able to handle failure and switch to the master passive. Now, other data centers may have the database in read-only mode, like it's replicated, the database is replicated from the main DC to the other DC, and it has the read-only database replication. Now, I want to process some event and save updates to the database. But where am I deployed currently? Am I in a DC that has a read-only replica? So what do I do here? So we wanted to reduce all this complexity from the developer. And now we'll see how we actually solved the cross-DC services issue in step-by-step fashion. So the first thing we, of course, allied in order to work in cross-DC fashion with Kafka is to have a replication service. So replicate topics across data centers. So let's say we want to replicate the master replica of Elasticsearch to other data centers. That's something that Elasticsearch still doesn't work well with, so we wanted to do it ourselves, replicate it ourselves via Kafka. So here we actually created our own replication service. Of course, there are other solutions out there. You don't have to do it by yourselves, but here for us it was really trivial to use Greyhound. We used a Greyhound batch consumer. So the original data center producer produces messages to Kafka, then they are consumed in a batch together in the replication service. And then they can utilize the ability to produce a batch via Greyhound to just utilize the Kafka SDK buffer. And so all this batch is also produced at once to the destination data center. And this is, for instance, a way to replicate Elasticsearch data and also other databases, other key value stores, etc. Now, how do we actually configure this replication service to decide which replication policies do we want to actually work with? So we actually use Kafka's compact topic feature. So Kafka topics can be served not only as for message streaming, but also you can think about them as storage. So compact topics are actually be thought of as key value stores, where values are stored as the latest value is actually stored, and you don't like delete 1 week ago, you just delete stale values. And so in our Greyhound back office, we have developers able to create new replication policies. Then we just keep them in this Kafka topic, and we just load it up into memory in the replication service. So the key will be a topic, and then the value will be what is the replication policy. So do we want to replicate across all data centers? Do we have like a custom replication policy between this data center and this one? And here we're back in our back office on the topics replication view, and we just we choose the topic and we specify the policy. So we could be all data centers, only the main data centers, like replicate between passive and active data centers, maybe databases, sorry. And that's developer's way to choose. But developer really needs to think about what he's doing here, or her or she's doing here. It's not that trivial to set up your configuration in a globally distributed ecosystem. So we wanted to simplify this situation in cases where you may have services deployed in data centers that have read-only replicas of your database. So for that, we actually added for Greyhound the ability to specify, I want to produce to the main data centers to get the events streamed to the main data center, so they will go to the main database. So how did we achieve that? So basically, you have the Greyhound producer, and you just specify two main DC, and then we have the main DC producer service that will produce. So we basically have a gRPC producer, a special kind of producer inside of Greyhound that just sends a gRPC request to the main DC producer, and then it will know to reach this HTTP request, this gRPC request, knows to reach the main DC according to the HTTP routing rules. And then this event can then be, from gRPC request, be transformed to a Kafka event, and then processed by services found on the main DC, and we can save the data safely and have conflict-free and consistent databases, which is very important. So Okay, that's nice. So now we don't have to worry about, if we know that we are deployed in read-only database data centers, then we write this down. But it still has a lot of constraints here. We really still need to think about where our services are deployed, how are they deployed, are they in only in main DCs, in all of DCs, what's going on? So we thought we want to simplify even further. We want to have complete freedom of deployment. And we also want to decouple producers from consumers. I mean, what's great about event-driven design, that your producer, when you produce the message, doesn't care who consumes it. It's not interesting. It's the responsibility of the consumer. The consumer, he has the control here to consume messages and decide what they want to do with them. So we thought we're working on just having messages produced and magically get consumed in the correct data center. Now, it's not really magic, because what we're working on is just having a dedicated state of topology for each topic where its consumers are residing, in which data centers our consumer groups are running. Now, remember that we have Greyhound in all of our services, so it's really easy to change Greyhound if needed to actually provide the state, and we already have it for a long time, so all we need to do is to maintain this state. And now what's left is for our application service to get this new produced event and check the current topology, and then it can say, okay, I know that we have consumer groups found in this DC and that DC. Great, so I'll replicate the messages over there. And now the consumers that know what to do, they have control here. We have consumers deployed next to our master active database, because this is, we control the service that is going to write to the database. So we create a Greyhound consumer there, and this replication service in Greyhound will make sure that it will get all the events that it requires. So now, in this setup that we've created, we can think about having a single logical Kafka cluster that's serving all of Wix services, no matter where they are deployed, and have like a sort of one global data mesh. And with the power of Greyhound, we actually have any technological stack at Wix actually using this event-driven style with this infrastructure, and of course deployed anywhere you need. And Greyhound is, like I said, open source. You can find it on this link in GitHub, and it's currently available for JVM languages, like I mentioned. We're also thinking about how we were able to open source Greyhound as a service to make it easy, although that's a little bit more of a challenge in how services are deployed in each organization. But it has all the features that I mentioned: parallel processing, batch consuming, resilient consumer, etc. So I recommend you to check it out. And that's it for me. Thank you very much. So I put all the slides in SlideShare and for you to have. And if there are any questions from the audience, we also may have questions from YouTube. I'll be more than happy to answer. Yes, so please ask, and then I'll repeat for the recording.
Okay, my name is Natan. My question is, I know for the last couple of weeks there have been a lot of DDoS attacks all over pretty much every company. Did it affect your work? And if it did, how did you not fix, but how did you deal with it?
Okay, so the question was that we, the person who asked the question is aware of a lot of DDoS attacks in recent weeks, and how was Wix affected, and whether and how we dealt with it. So I'm not sure specifically about current events about DDoS, but of course Wix has a lot of experience with DDoS attacks. So basically, I know that we handle it. The most important thing, of course, is to quickly be aware of this situation. Of course, we have a lot of different metrics, a lot of different alerts all around our services. We have like a dev-centric ownership at Wix. So for each service, there's a dedicated developer who knows what's going on and is on call and knows if there are specific alerts. And then once the situation is brought to the attention of the developer through these automatic alerts, then we need to start working on it. There are a couple of ways you can deal with DDoS attacks. Of course, you can block the IP and see how you can isolate the attacker but not affect the other parts of your system. But of course, using Kafka is a great way to handle DDoS attacks, because at the worst case of it, you will have a ton of messages being produced to a Kafka topic, but because of the reverse control here, not like request-reply style that I mentioned, the consumer has the control. And if the consumer is currently not able to keep up with it, then there'll be a lag increasing. So all that we need to do is be aware that we have under DDoS, ignore all of these messages, and continue on with our lives. I hope that answered your question. Yes?
Let's say that you're deployed in some kind of a web environment. At the end, the user is using HTTP. He wants to request and then get a reply. So how do the server that replies to it receive the response?
That's a great question. So the question is, we're working with a browser that has HTTP requests, and that means that we're working with request-reply model. How is that combined with event-driven design? So I think there are two ways to tackle that. You can have usually like the front-end service, which interacts with the browser. It will receive the request, and then it can start working with the event-driven part of your system, interact with it, and keep status in a database in order to know how to answer the browser if it keeps requesting what's going on, have you finished, etc. And it can keep the results in database. So once it gets the result back, it can fetch the results from the database in order to respond to the browser. Another way, which is gaining popularity in Wix, and I really like, is to combine Kafka events with webhooks. So, of course, HTTP has the ability to have webhooks, and in such cases, and we actually deploy it for Greyhound back office, the Greyhound admin. So it is deployed all over the world because we want information on all Kafka clusters. So we start off with a browser request. It becomes then in our front-end service a Kafka command. Then it is replicated to all the data centers, processed, and the data center it's filtered for the data center that actually is interested in this command. And the response is actually brought back through our dedicated webhook service. So the original request will have the webhook channel ID. It will travel all along the Kafka flow. And then when we request, again via Kafka, for our webhook service to actually send over the response to the browser, it will also have the channel ID, and the response can go back to the browser via webhook. Sorry, WebSockets. Did I say webhooks all the time?
Yeah.
Sorry, I'm working on webhooks these few last days. WebSockets, WebSockets, WebSockets. Sorry. Yes?
Hello. I have a question. How do you manage things like documentation and education in Wix about stuff like guidelines and best practices and everything that the developers need to know in order to correctly write the code and run in scripts, replays and stuff?
That's a great question. So the question was, how do we deal with documentation, with education? We have so many developers and so many topics. Like I mentioned, they overloaded our cluster. So how do we actually allow for discoverability, right, and education? So in terms of education, I would say the most important thing is to keep the API to convey as much as possible what you require. So we're working really hard on making the best APIs we can so that it will be really easy to use them. In terms of discoverability, I know that a lot of people in the Kafka world use schema registry, where they can have the Kafka topic schemas maintained. But in our case at Wix, we actually have our own documentation website where you can find all the events of all of the services. And we used to work with JSON, but now a lot more protobuf. So we have just part of the CI build. It reads this protobuf, and then it knows to automatically update this hub where you can find all of the services and events. And like I said, we already have a lot of work on top of Greyhound, including a lot of applications that just specify that they want to produce and consume via protobuf. So that means that it's even more natural for all of the applications to produce the information that the hub is required. So it's not like 100% coverage, but you can find almost everything you need there. Yes.
The sidecar is open source, and how it works, like how it package, I don't know, Go, Python, Node.js.
Okay. The question is the sidecar open source, and how is it managed on other languages like Node, Python? Okay. So like I said in the talk, we currently haven't open sourced Greyhound as a service. So we only have the JVM library available as open source. Basically, we just spin up a regular service at Wix, and it implements a gRPC service, and then it just invokes the correct Greyhound API. It also, it works as a gRPC client, where the Node application or Python application open a gRPC service, and then Greyhound, and then this sidecar, just when it consumes messages from Greyhound, it invokes the gRPC service from the Node application. We are thinking about how we can open source it. Like having Docker out of the box, something like that, and hopefully we'll be able to have something like that in the coming year or something like that, I hope. And does that answer your question?
Yeah.
Okay, thank you. Okay, so do we have questions from... I have one question, one you marked. Can you describe the scenarios where saving events to disk helped you out? Sure. So we're talking about the Greyhound resilient producer, and we had situations where a specific pod has some network issue, and it can't access Kafka. So Kafka has very high resilience. It's working. Data isn't. You can almost always get availability from Kafka, but there could sometimes be network issues, and then you want to restart the pod and have messages be read from the disk and then produced to Kafka when you gain the networking back. And we also have a complex mechanism to make sure that messages put on disk are never actually lost whenever Kubernetes wants to take away the mount of the disk. And then we have a second-party service that will handle these messages for the deleted pod. And okay, I think that's enough Q&A for now, and I would like to pass the stage to Tim.
To the head on the TV screen. Thank you very much, Natan. That was awesome. So, everybody hear me? Yeah? All right, I'm going to take that as a yes. There we go. Let's get a presentation shared. All right. If I could get a quick audio thumbs up that you hear me and see my presentation right now. If somebody could just say, yes, that's good, I'll go on. All right, I see something in chat. Yes, is what I hear. Perfect. That's all I need. All right, I'll get started, and I will have a way of getting your questions. If you're watching the live stream on YouTube, they will come to me, and otherwise, everybody else in the room, we can talk afterward. So, all right. You know, I've had this kind of thing I've been thinking about in the last year or so. Not just the history of Kafka, but the way Kafka penetrates organizations, the way people start using it, and then what it ends up doing to them. And I think I've seen a parallel between those two things, between the way Kafka has developed as a platform and the way, even if you start today, like if you weren't using Kafka 8 years ago, like some crazy early adopter, you just start today, you kind of like relive that same process. And I've been thinking of this idea of development, and I don't mean software development, I don't mean real estate development. I mean like developmental processes that people go through, that living things go through, that teams go through. And I think that's kind of the way what I want to talk about tonight is these developmental stages that Kafka has gone through, and the developmental stages that teams and organizations go through in adopting Kafka. And it's nice to look at that because we can kind of see where we are along that process. And where we are is important, and it's good. And you know, we have some idea of where we're going to get by watching other things having developed. Part of this is probably influenced by the fact also that I just became a grandpa in July. That's me with Alexander Flynn. And you know, at this stage of development that all of us who are listening were at this stage at one point, like you don't do much, you know, you sleep and you eat, you cry a little bit. And you know, what do you do with a person like that? Well, you hold them, make you feed them, you keep them clean, give them a warm place to sleep. That's really all there is. You know, there's not like a whole lot of interaction. But hey, you know, babies are great. And we go from there through other stages. He's just 4 months old now. This was July, so he's still pretty small. But he'll smile at you now, and he kind of, you know, he'll laugh at things a little bit. He's developing, you know, he's going through stages. Companies do this. I see companies do this. So I've worked for a few startups, and I think that there are some kind of main phases of startup life. I think kind of from founding to about 75 people. Once you get past around 75, then it feels like the really early on people have a shared identity. Like, you know, here we were the early folks, and now all these new people are here. And it's not like it was at the beginning. You start to have that sense around 75. Then around 250 people, there's this other phase you go through where things really start to feel formal, and there's executives who are leading functions, and it's like, you know, kind of a real company. It's still pretty small. It's not 5,000 like 5,000 developers like Wix. And then I think around 800 people, you really get to the point where leadership is focused on process and scale and things like that. And it feels like a totally different thing. So companies go through these phases. People do, companies do, software does. And you know, in America, this is a very recognizable kind of macaroni and cheese. You could tell by the color that it's Kraft macaroni and cheese, because actual cheese is not that color, but the powder that this stuff comes with is that color. And this is like a very stereotypical little kid food in the United States. So you could be 3 years old and just want to eat this 3 times a day and think this is a fulfilling life, and I can't believe I get to eat this wonderful food. And then you as an adult might come back and try to eat it and think, well, you know, I have fond memories of making this when I was 10, but this isn't good food. You know, so it's important to realize that that little kid who loves Kraft macaroni and cheese isn't stupid or isn't bad. It's just at an earlier stage of development. And then you, at a later stage, you have different requirements. There's other things you want to be eating. Kafka works that same way. And I think the organizations that adopt Kafka work that same way. We go through these same kind of phases. And it's important to not to look down on the macaroni and cheese phase, but also to want to grow past it, because it's not good to stay there. So let's look at where we start. A lot of companies start. Now, you just heard Natan give, frankly, a very sophisticated account of a company that has made deep Kafka adoption and done, I don't want to overly flatter him, but honestly, some industry-leading thinking on how to do this right. A lot of companies aren't there, and a lot of companies start with something very simple, which is just integration between two things, right? There's something happening in one application, and I need that to happen. I need that to get to the other application. So this is the very, very simplest thing you can do with Kafka, and it's almost like what you can do with messaging systems, right? Sometimes this is where Kafka kind of competes with messaging systems. Now, Kafka's not a messaging system. It's not a direct competitor for ActiveMQ or RabbitMQ or any of those. It's a different kind of thing, but this early use kind of feels the same way. And it's interesting to look at what had to be present. If you think about little kids, remember, I'm trying to make this human development analogy here. When you think about little kids, like a 3-year-old is not good at very much. One of my daughters, who's herself, she's all grown up, she worked for a few years coaching toddler gymnastics. And she always said that the mission is not for these kids to learn gymnastics. It's for them to learn to obey somebody who's not their mom and to not hit their head on things as much. So she loves kids, but she realizes they're just not good at much. But even so, people who are 3 years old are capable of some really sophisticated behavior of like object recognition and natural language. And fine, they're not that good at talking, but they're better than Alexa a lot of the time. So, there's a lot of capability that had to be present in Kafka for this to work. We had to have topics, right? Topics are kind of the fundamental thing, the fundamental piece of Kafka. There is no Kafka without this. And the very first, right out of the gate, Kafka had this commitment to topics being logs, to being persistent storage. Natan talked about that, how it's possible to use topics to store things, and so they are. And Kafka figured out had a way right away from the beginning of partitioning topics. You could split one up into multiple pieces and put those pieces onto different machines, run them on different machines, which got us, it brought up the question of how to assign messages to topics. And Kafka came up with this way of by default, using the key. Each message is a key value pair, and it would hash the key before assigning it to a partition. And based on the hash of the partition, it would write it into the same partition. The same key always goes to the same partition. This is just Kafka right out of the gate. So producers, there was a producer library, and there still is a producer library baked into Kafka. This handles all the network plumbing and retries and, all that hashing stuff I just talked about. That's what producers do. And consumers, Kafka had a way of consuming from partitions right out of the gate. So toddler Kafka, you had this ability to have multiple consumers on a topic, which was super interesting relative to the messaging systems that had come before, right? Just because one consumer is reading from a partition doesn't mean another one can't. And you had this way of horizontally scaling consumers by adding an additional instance. The consumer group and the cluster would cooperate to reassign partitions fairly between the topic and the consumer group. This is all, and that, if you think about it, you could kind of get a horizontally scalable, elastically horizontally scalable application without doing anything. Now, if you've done this before, that's kind of a big kind of. There are things that are missing here. But again, it's like a little kid. Lots of speech, lots of image recognition, lots of relationship capability. There's all kinds of things, even though they're not good at much, that they still do. And so consumers worked that way. Now from there, people start to, again, the initial use might be just to ship events from one place to another. There's a bunch of functionality that has to be present in Kafka for that to work. But things start happening. So let's suppose that shipping events from one place to another is this real common use case called mainframe offload. Now, if you don't have any mainframes in your life, this is not obvious. If you do have mainframes in your life, it is obvious, but I'll explain it real quick. The idea is that you get charged for computation, for the time a program spends running on a particular CPU. You get charged for I/O. So it's this very by the drink sort of billing model in the mainframe. I don't know, it's kind of like the cloud. We pay per unit of computation and per unit of I/O in the cloud. Mainframes were doing that 2 generations ago. But if you're spinning up some new application, it could be expensive to do lots of queries against the mainframe. So what people will do is they'll offload that data into a Kafka topic. They'll get it out of the mainframe database and put it into a topic, and then maybe consume it in that consuming application and populate a temporary database, a materialized view of that data in a database local to that service or to that application. That's just the basic shape of mainframe offload. Now, once that data is in that topic, it's basically free to access. You're not paying per query anymore. So what happens is other things grow up. There's other applications that want to read from it. Maybe you want to store it somewhere for the data science team to get to it. You want it to be searchable. Maybe there are other legacy applications that you want to offload into Kafka because you realize that having data in topics is actually kind of valuable. Once you start to use it, you want more data to be in topics. So it goes from this point to this many point to many point interconnected thing, something like the central nervous system. And before you're thinking about Kafka is very sophisticated, because saying it's a central nervous system implies that you've got some like big strategy and unified application architecture. Before you even get there, you still have this web of data, and then you tend to evolve very naturally, develop very naturally from that single point to point thing to this general integration platform. But there's a problem here, and that's those arrows. All those arrows, once people started doing this, they realized they had to write the code for those arrows over and over again, which is not particularly rewarding because it's exactly the same thing for you to dump data into Elastic as for your competitor to dump data into Elastic, or to read from a mainframe or read from a relational database. And so Kafka Connect entered the scene. This became, in 2005, a capability that Kafka had as a platform. The platform developed to keep pace with the things it was trying to do. And again, if you have kids, if you think of the way their development proceeds, suddenly they're able to do some new thing. And so they do a lot of it, and that might cause them to develop some other skill, like they're able to speak now. And now suddenly they have to develop social skills and learn, well, you don't say that kind of thing to strangers. If you have young children, then you know that's painfully true. Well, Kafka had to grow Connect, and Connect is this general purpose data integration framework that's a part of Kafka that now has a pluggable system for doing things like writing into Elastic, writing into S3, reading from a relational database. Confluent keeps a hub of these things, hub.confluent.io. There are connectors, converters, single message transforms, all the modular pieces of Kafka Connect that are all available for download here. And of course, you can find this stuff on GitHub. I mean, it's everywhere, but Confluent gives a somewhat curated collection of those things. All right, so a new capability and kind of a new way that Kafka tends to develop and things that start to happen is something happens to ETL. Once we've got data in topics, things happen. So remember how ETL used to work? You had I'm showing it as one big giant mainframe, obviously over on the left there, that's 200 databases. It's all kinds of crazy things. And we have some nightly batch process that reads from those, does a bunch of cleaning and aggregating and pre-computing, and dumps the process data into a specialized database. So this whole really tradition grew up around the idea that we needed to run reports. And the best we could do was to do that nightly because it was computationally expensive. At the time, 30 years ago when people started doing this, it was difficult. And it was this nightly batch thing. So if you wanted to understand what happened in the business yesterday, that was cool. Well, think about what happens here though. I'm already doing this offload. I'm already tending to want my data to live in topics. And if my data lives in topics, I can still write a batch process at night if I want, But the way people use analytics is honestly changing. It's not so much that a report gets prepared, it gets handed to some important person in an oak paneled room in the morning describing what happened yesterday or last week or something like that. But increasingly, analytics is used to drive real-time decisions that people, even people fairly low down in an org chart, individual contributors, kind of need to know what's going on in some ways. That's a change in business that kind of coincides with this change in the way we can do things. So we've got this new developmental capability. We've got data in topics. Well, now I can just write a stream processor that consumes from that topic, does the aggregation in real time, and emits results to some new topic, which of course is now accessible to other applications, to storage, to search, to whatever we want to do with it. And I've already got the ability to do this, all right? If I've got connect, that's nice. Connect keeps me from rewriting too many of those arrows. And I've got the ability to consume and the ability to produce, and I can write a program myself. I can do this, but this started to show that there was something new that needed to happen, right? Once you're writing all those stream processors, you're doing the same thing over and over again. You're going to be doing grouping, windowing, aggregating, joining, enriching, all this kind of stuff that just happens in real-time ETL. We don't want to do that over and over and over again. So Kafka Streams emerged. That's this Java API that kind of borrows from functional concepts that rather than just saying, your abstraction is a topic and a message, now it gives you these higher level of abstractions called streams and tables. These are objects in the API that correspond to topics. They're like layers on top of topics, but we get to program them like we're programmers and do things like if you have a stream and you want to group by some field, well, you can turn that into a grouped stream by identifying that field. If you want to run an aggregate, a reducing function over that group, you can provide that function and it gets run for you. So this much higher level of programming than we're used to with just consuming. Also, consumers were scalable, but they really didn't do anything with state. And this is really another great example of this developmental mindset. Yeah, you could scale out, but if you're doing anything stateful, you kind of had to, really restart the consumer group or just spin up a new one and turn off the old one. That process was difficult. There was no way to do that dynamically. Well, now Kafka with Kafka Streams has grown this new capability, this kind of maturing capability of doing that better. And, you don't have to write boilerplate for doing all the stream processing and real-time ETL kinds of stuff that people had to do, computing aggregations and joining and all that kind of stuff, because you don't want to build that framework code. Just like you don't want to build Kafka Connect over and over again, you don't want to build this kind of framework code because it's really hard to do. And if you don't know Kafka, I think many of you in the room know Kafka Streams. If you don't know it, its main interesting opinion is that it runs as a library. So it's a part of your consuming application. It's not a separate stream processing cluster that you spin up. It's just functionality that you depend on as a Java application. And you code against this API and now you're a Streams app. Streams code looks kind of like this. This is, I don't intend for you to actually study this. The Confluent DevRel team has a GitHub repo called Demo Scene. That's Confluent Inc/demo-scene. And this is the movie rating demo that's in there somewhere. So it's fairly readable. I mean, this is scrolling too fast. We're not really looking at it, but it takes a bit of code to get things done, which gets us to our last really, feature in the platform, and that's KSQLDB. So this is like Kafka Streams, but in SQL is kind of what it is. The same stream and table abstractions, the same filter, join, aggregate things. It's extendable in JVM languages. You can write, it's a really, really simple API, just like a couple of annotations, and you can write a custom user-defined function or user-defined aggregator and deploy those as a part of your KSQLDB app. It doesn't run as a library with your Java program, obviously, because it's parsing and executing SQL. So there is its own, you have your own KSQLDB cluster that you throw queries at and it executes them. Architecturally, it looks like this. You got some source of events, they go into a topic, KSQL DB query consumes from that topic. There may be many topics that a single query is consuming from, but at least one, and it does, the computation runs over the cluster, and then it emits its results to a new topic. And that code looks something like this. This is a little bit of a cheat, but this is basically the same computation that Kafka Streams code was doing. Now, to be really, really the same, I'd have to show you some DDL. There'd be a create stream and a create table, and might have to monkey around with one of the streams to get the key right. So to say all of that Kafka Streams shrinks down to this KSQL is a little bit not true, but the basic heart of the computation is expressed here. And it is, of course, being SQL, more expressive than Java code. That is, for each unit of code in SQL, we're talking about more work being done than in the equivalent Java API. That's definitely true. So where does this get us, though? So we have this now kind of completed platform and this new set of capabilities, but let's talk about what this ought to do now to application architecture. This is like, all of a sudden discovering you're an adult and you can engage in adult relationships and talk to people and eat adult food and drink adult drinks and think adult thoughts. Now, what's your life going to be like compared to when you were 12 and you didn't have those capabilities? Well, let me tell you that story from an application architecture perspective. And this, I think, builds a little bit on some of the things Natan was talking about. He was giving us a really big overview of just the way Wix uses Kafka and the capabilities that Greyhound has. And he talked a little bit about how their services interact. So this, and we could talk later about how Wixy this is, but this is a good vision for what Kafka ought to do to application architectures. Let's start with doing this with RPC, or synchronously integrated microservices. I'm going to be doing an e-commerce system, and very, very minimal e-commerce system, such as might fit on a slide. But right now we've got a service that takes orders and a service that lets me manage user accounts. That sounds like a good start, right? So we can take orders, we can manage accounts. Let's see what else we have to do. If an order comes in, the order service has to call synchronously the payment service because we need something to get paid, right? Well, that's going to call some payment gateway and a response will come back, and maybe then we'll have the payment service call the shipping service. We could also have the order service call the shipping service, but hey, this works better for now. So the shipping service is ready to go, ready to ship this thing, but unfortunately it has a user ID and not a name, address, and phone number. It needs a name, address, and phone number because our shipping service, our shipper, doesn't know anything about our user IDs. So now it has to call synchronously the user service, which will look up that user and return the name, address, and phone number to the shipping service. So it can now enrich the order object with that data, send it off to the warehouse. Warehouse says, okay, we got it. And that is complete. Now, that's all synchronous. That works. It's in a sense, it's okay, but of course, there are problems with all that synchronous integration. So let's refactor that to events. This vision that I'm about to propose here is really what I think Kafka does, and what adult Kafka does to application architecture. So that first synchronous call between orders and payments, we're going to replace with a topic. So now all orders does, when it's done validating the order, is produces a message, and that's it. It doesn't wait around to make sure the order got shipped. It doesn't know whether the order got shipped. That's somebody else's responsibility. It just puts a validated order in that topic and expects somebody else to pick it up. And of course, payments is that service. Payments can now consume from that topic, do the payment gateway thing, which, by the way, is still going to be synchronous. I mean, there may be no getting around that. Maybe that's just what our payment gateway API is. When that response comes back, though, it will be able to pass it on to shipping, which it does asynchronously. You do that by producing a message to a topic, and the shipping service consumes that message. Does payments know that shipping is consuming that topic? No, it doesn't. It's not up to payments to know what happens next. It's up to payments to do its work and produce the result. Now, this is important because with with this sort of toy system here that, again, it's like pedagogically useful. It's simple enough that everybody can just kind of understand it at a glance, and we can focus on other concepts. Now, if you're really building an e-commerce site, it's not for services. It's a lot more than this. But with just this simplified thing in view here, something cool has already happened. Now, as I said, orders, we produce the message. We don't care whether it gets paid or whether anything happens with it. Payments picks the order up, does the payment, produces the result with, you know, the order object enriched with a payment reference ID or whatever. Doesn't care if it gets shipped. It has to trust the other services to be adults. Now, we know it goes order, pay, ship, because we can look at this, but the services don't know. The other thing that we don't know at this point is what else might happen with that data, because RPC calls are ephemeral, right? The call happens and the result comes back and it evaporates. Now, something's getting logged there, right? There's some way of observing the system, but that's logging for the sake of observability, not for the sake of being a system of record. Here, the system of record, the interaction of the components of the business are now logged. And if I want to stand up some other service that maybe detects fraud, and maybe I need both of those topics, and like I need to join them somehow to be able to do fraud detection and some other data sources. I have that. What if I want to spin up a service to reward frequent customers? Well, I could consume that order service data and I could build that service. Like, you have people in your company who can discover the data and build valuable things without you knowing. All you're doing is producing your result, but the data now is there, and you can have this kind of ecosystem effect of functionality emerging in the organization when other people in other parts of the business discover it. That's cool on its own. There's another cool thing here. Data gets in the way when it comes to microservices, right? It's usually easy to functionally decompose our system. Like here, we have this shipping service and the user service, you know, that's easy enough. But shipping needs that data, that user data. And we're trying to avoid synchronous interfaces. So what do? Well, it's straightforward to create a change log of what happens to the user data. This can be done in Kafka Streams. This can be done manually. This can be done with Kafka Connect. But every message in that new topic is, we produce a message there when we create or update or delete a user. And with that change log now, and again, with Kafka Streams, KSQL-DB, this becomes pretty trivial. I can materialize that as a local read-only view. I now have in-memory key lookup access to users' data, so that when I need to enrich paid orders with user data, I could do that in a performant way inside the shipping service, and I don't have to have any kind of direct access to the actual database of users. The user service is mediating that data to me by way of this change log, this log of immutable change events. So a bunch of cool things happen when we've got this fully grown platform in place. And remember, we started by thinking about the idea of development and developmental phases, and this picture of macaroni and cheese. I hope it's not like super unappetizing to you. I mean, you've probably eaten by now, but you know, again, a lot of little kids just consider this to be gold in America, and I've never understood it. My kids did. I still don't know why, but they grow out of it. And this is an important phase for people to be in, just like adulthood is. So if you look at how the platform developed, the phases it went through. Early Kafka, what did it have? It had topics. It didn't even have replication at first. That wasn't until 0.8, I think in like 2012, that Kafka had replication. It had a standardized data integration framework, Kafka Connect, 2015. Schema management, the Confluent schema registry. We didn't even talk about that. That was a thing that came along. Kafka Streams in 2017. Suddenly, this is looking like a serious framework. There's this way to do advanced computation, data integration, logging. You know, it's kind of all there. A SQL has to happen, and so Confluent created KSQL-DB, and Confluent made a cloud offering. And this stuff has to happen in the cloud. There are lots of different places to run in the cloud. My employer is one of them, and with that in place, it feels like, okay, this thing's fully grown. Now, we always kind of sit where we are and see ourselves as grown and mature. And I'm doing that with Kafka right now. I'm thinking the pieces are here. Man, there's still stuff that needs to grow, like schema management for the enterprise needs to get all this cool stuff. Like, yeah, okay, that's all there, but boy, we're fully grown adults. Just like when you're 12, you think that, and I don't know how much growing we still have to do, but it really feels like this is pretty good where we are. And it mirrors the stages organizations go through. You might start by trying to ship events from one place to another. And maybe that's offloading a mainframe, maybe it's some other legacy application. Pretty soon you've got lots of things wanting to talk to each other. You're wanting to use Kafka Connect and do data integration. And sometimes real-time ETL is what motivates people to start with Kafka. Sometimes people just jump right into this stage. But once you've got data and topics, you're going to want to do computation on it. That's just how it works. And then finally, we see that vision of microservices that I presented, which I think is an evolvable and scalable software architecture. I think that's something advocates of microservices have been saying for almost a decade now, but hasn't really been true. It's starting to be true. It's like as fully grown Kafka, we can kind of do that now. Anyway, think about where you are in this process. Maybe you're at the very beginning. You came here because you're interested in learning something. Maybe you're using Kafka like a message queue at your company. Maybe you should be sending a talk to Kafka Summit London. The CFP is open right now. You should Google that and put a talk in if you'd like about what you're doing. Like the stuff Natan is doing. You should be talking at Summit. There are probably other people in the room where your usage of Kafka is adult enough and sophisticated enough. Darn it, people need to learn what you're doing. So wherever you are, it's a good place. And it's good to see how this process works and how you're likely to continue along this spectrum if you keep it up. Hey, if you want to know more, especially if you're getting started, check out Confluent Developer. It's a website we made a while ago, and we just put a bunch of new content on it this summer. It's there for you, so check it out. With that, I say thank you. And I'll take questions. Or also say goodnight. This is water, by the way. I feel like I should clarify that. This is it's not gin.
So Tim, can you hear me?
Mm-hmm.
Great. Well, thank you, Tim. It was a great talk, and I'm wondering if anyone has a question for Tim. Yes. Okay. So please use the microphone.
Hi. My name is Gil, and I want to take you back to the microservice architecture example. So there, okay. In one of the last sentences, you mentioned that the shipping service needs the user, some user information, and with, yeah, exactly that one. So you'll effectively do some kind of caching or duplication of the relevant user information that the user service will produce as logs, and store it in the shipping service database. Did I understand correctly? Okay. And in some cases, in a small user database example, it may be straightforward, but in some cases, the information might be very large, or there'll be many different rows or instances of the entity. And then I wonder, like, sometimes duplication is not an option. Maybe the shipping service only does shipping for 0.01% of all the users, and then it's not worth it to duplicate all the information. So how would you go at it?
Sure. At the end of the day, we're engineers, and there aren't solutions. There are just competing sets of trade-offs, right? So when you've got something like a very large database of users, then the value of eliminating the synchronous call to the user service might be a lot smaller, smaller than the value of the cost of doing the duplication. So yeah, in a situation like that, there definitely are sizes of data sets where this becomes not fun. There is a scale story. Kafka Streams and KSQLDB both have a scale story. So it's not like this all has to fit in process in one JVM or it doesn't work. It does scale horizontally, but there'll come a time when that is going to feel stupid, right? Where there is real value in eliminating synchronous interfaces between your services, but not at any cost, and you have to make that trade-off. So I'm not, I realize I'm not giving you a specific answer there because it's really that I can't. What I'm saying is this is a super good idea because this keeps you from being coupled to the schema of another database directly, and it keeps you from doing synchronous calls, and those are both real good things. But bad things might happen to you also in your particular system, and so you might decide it's okay. I'll keep the synchronous interface in there.
Thanks. Actually, the answer is perfect. Thanks.
Anytime anybody says this pattern is good for absolutely everything all the time, stop trusting that person.
Hi, I have a question. So basically, you said right at the beginning that Kafka is very different from RabbitMQ, but from orders to payments and from payments to shipping, you use Kafka exactly like I would use RabbitMQ. So how is it different? Why would I prefer Kafka instead of RabbitMQ for this kind of case?
Sure, a couple things. One would be Kafka is a log, not a queue. So remember I talked about how we have a durable record of the history of orders in that. Let's see if I can get a pointer going on here. In this topic down here, that lives forever. So payments will read from it, and payments, once it reads a new message, is not concerned about the old messages. They have already been processed. That's sort of queue-like behavior, right? I have the new thing. I can completely forget about everything I've ever done before. I just want this new thing. That's how we use a queue. A log, though, is a durable record that goes back as long as we want. And that can be a day, that can be a week, that can be a year, that can be infinite, right? I mean, lawyers will never let you do infinite, but in principle, it can be. So this is actually a system of record, a durable log of what's happened in the system. So that's very different from what Rabbit would do.
So
and I don't want to gloss over that. That's like a really important thing. The fact that we are remembering the events and storing and replicating and safely, durably storing the events. We now have the opportunity to use that event log as the system of record and not a database. And I didn't go into the database versus topic sort of trade-offs here, and that's to some degree that's a different talk. But it can become an important thing and a powerful thing to start using topics as your system of record rather than databases.
Oh, okay, thank you.
You got it, man. Good question, by the way. I really like that question. I wish more people would ask that question. I got some on WhatsApp here.
Yes, from YouTube chat.
Yes, from YouTube chat. YouTube people, thank you for asking questions. I'm just going to take a few of these. I'll hold my phone so you can see that I'm. That's like a good prop, although I am literally reading from it. How do you manage the contract between producers and consumers? The contract between producers and consumers is the schema of the message. So the message is a key value pair, and it's really the value that's the thing that you're passing, right? And so what it is you are passing is the contract. And that's going to be some business object serialized generally in one of three forms: JSON, protobuf, or Avro. And the layout of the fields, the schema of the message is the contract. And so the Confluent answer is the Confluent schema registry. And that's not all that Confluent-y an answer. It's not like you have to be a customer of ours to use it. It's free to use. So that is a component that runs adjacent to your Kafka cluster that helps producers and consumers know whether the current version of the schema that they have is compatible with what's in the topic. Because you're going to have probably more consumers than producers, and very likely not everybody's, well, hopefully not everybody is going to get versioned at the same time. You want to be able to release new versions of services at different times. And so the schema registry helps you make the assertion that you can safely produce or consume something that has a different version. But the short answer is that contract is schema, and schema registry is a good thing to do. Next question. Do you plan, sorry, I need to make sure the phone is in the frame here. Do you plan to provide a Kafka Streams library for languages other than Java? So that is a Kafka question, properly a question for the Kafka community and the Kafka PMC. I think the answer is still no. I don't think that work is really happening. There is a pretty decent partial JavaScript implementation, and I haven't checked up on it recently, so I don't know how much it's still moving forward, but it's a lot of work to make a stream processing library. So it happened in Java. I don't know that it's going to happen soon in other languages, but this is why we made KSQLDB, so you still have a stream processing story that's independent of the language you're using. It's not the same. There are times you want to use Kafka Streams over KSQLDB, even if you're 100% Java in all your life. I understand that, but KSQLDB is a good substitute. Any plans to open up event schema registry? It is open. So briefly about that license, it's licensed under the Confluent community license. And that makes it, the code is available and it's free to use for anything other than making a hosted schema registry service. So pretty much no matter what your business is, as long as it's not schema management in the cloud, it's completely free to use. So it's that is open and available, and you can download it, build it, and run it, and never pay anybody a dime. Did Wix face any problems in geo-replication events? Let me get back to that. I'm going to eat up all my questions, and I'll turn that back over to Natan. What's the proper way to do auto-scaling in Kafka? I'm going to go with, all right, this is a cheesy answer, and it's like a super Tim works for Confluent answer, but use Confluent Cloud, please, or some other hosted Confluent. Doing your auto-scaling is complex. It involves rebalancing of partitions between brokers after scaling and other things. It can be done, but I don't know that there is a proper way to do it, and I would strongly recommend using a managed service. If you can't use a managed service, then there are probably some good conference talks that will deep dive into that, but we can't do that tonight. Suggestions for frameworks to integrate existing applications with Kafka. I'm not sure what the integration requirements are beyond what you would do with a library, you know, like a language library or Kafka Connect, you know, if it's an actual external thing like Salesforce or a database or file system or some, you know, some source of data to bring that in or to output. So that's the best I got there. And Natan, did Wix face any problems in geo-replication of events? That's a question from YouTube. If you want to be really mean and just give a yes or no answer to that question, I can predict what it's going to be. But maybe you could talk about those.
Like I mentioned in the talk, our own replication service. So we of course had issues during the last few years with the replication service. Usually it means that like a lag will build up in the some instance consumer, and we require to maybe increase the amount of pods that we use. When we moved to our current version of batch consuming on top of Scala Zio, which is a library that's very good for asynchronous and parallel programming, then our throughput rate really increased dramatically, and we're seeing less issues with our cross-DC replication service these days. And we also need a lot less pods to actually do the consumption. Utilizing Zio fibers, I won't get into that, but if you're using JVM, I highly recommend checking out the Zio library. Okay, so I think we don't have any other.
Let me see here. Yeah, no more questions on my end.
Okay. Yes, I think we can. Let's have one last question. Yes.
Hi, thanks for the talk. It was a great one. Regarding managed services, can you talk a bit about the differences between the Confluent managed service or AWS Kinesis, maybe even talk about Google Cloud PubSub, even though it's more of a message queue. Just talk about like all the options, differences.
I mean, I'm happy to. I always feel like I'm selling things, and I'm careful about that. I mean, I don't mind saying, hey, there's a Confluent Cloud, it's cool, you should check it out. But I want to be careful with trade-offs, because obviously I represent Confluent, and you're here at a meetup for me to do things other than sell you things. But fine, you asked. Remember, you asked. Basically, yeah, PubSub, Google PubSub is powerful, and it gets used successfully in a lot of systems. It is more of a queuing technology. And so when you need a queue, it's a perfectly reasonable thing to use. It's also, well, yeah, it's a cloud vendor specific thing. And for choosing kind of fundamental data infrastructure or event infrastructure in that case, and committing to one cloud vendor, it happens, everybody does it. I never recommend it. So 30 years ago, software was sold in the enterprise on the golf course, and developers were told what to use. They found out, oh, this got bought, and now we're using it, right? Then open source happened, and now as a result of the many changes there, software might still get sold on the golf course, but it doesn't get sold on the golf course unless we're already using it, right? At the grassroots level. We have to be making adoption decisions for that sale to work. And that's why companies like Confluent pay people like me to do this, right? That's kind of the business end of that. Cloud vendors still get decided on the golf course. We're kind of back to that, right? When a company makes a commitment to a cloud vendor, that is not a thing that happens at the grassroots level. That happens at the executive level. So I say that to say, you could be Google now, and you might not be Google in the future. And so making a commitment to a Google-only service for something fundamental when the executives decide that you're going to re-platform to Azure or whatever, and that does happen, that can be unfortunate. So something like even MSK, if you're in Amazon, right? That's Amazon's managed Kafka. The APIs are still Kafka APIs. You still have the safety of knowing that you could make that a different Kafka somewhere else, and you're going to have work to do, but it's not every single line of code and every assumption you've ever made. Now, when you upgrade, if I may say that, to something like Confluent Cloud, now you've got an actual cloud vendor agnostic thing. And still, when the CIO says you're not on Google GCP anymore, you're on Azure now, you still have work to do. It's not like you just go into the Confluent Cloud interface, there's a select box, and you pick Microsoft, and all the data moves over. It's still hard to change cloud vendors, but the platform you have built against is one whose APIs will absolutely be constant between vendors. So, I'm always trying to remind people to try to stay cloud agnostic when they can. And if what you need is queuing, then PubSub is fine. But like we were talking about before, queuing and logging are different things. And so the choice to use Kafka isn't really a, should I use PubSub or Kafka? It's more of a, am I using queuing or logging? And those represent in maturity. Remember, early on, with simple use cases, they look exactly the same. In a mature system, they're fundamentally different. And one has capabilities the other that doesn't have.
Gotcha. That's a great answer. Thank you.
So I think we have a couple of questions on YouTube chat. If Tim, you want to check out your phone?
Okay, yes. Confluent Cloud compared to AWS MSK. So I talked about that a minute ago. The basic idea is MSK is like somebody else running your Kafka cluster for you, but you still see the details. Like you're thinking about the number of brokers and all that kind of stuff. The interface that Confluent Cloud is trying to give you is something like what you might call serverless Kafka. I don't want to think about brokers. A cluster becomes a namespace for topics, right? It's where you put topics. But what are the details of the scaling of that thing? I don't know. That's all done for me in the cloud. I shouldn't really know that. So that's the basic shape. You've also got MSK is the Kafka component inside the broader AWS ecosystem, which is enormous and complicated, does everything. Confluent Cloud is a complete event streaming platform. So if you're building your system on event-driven architecture, the things that you're going to need as a part of that event-driven architecture to manage events are going to be within Confluent Cloud, by and large. That's our goal anyway, to be a complete platform, not just a Kafka component inside an ecosystem. Okay, we need to store database transactions to Kafka. The transaction items can vary, but we need all of the items of the same transaction on the same partition to keep the order. Do you have any idea? Yeah, absolutely. You should have some kind of transaction context that you use to partition that topic. And this is one of those cases where the same data can exist in multiple partitions because you might not want that ordering. There might be other consumers that don't care about that ordering, but you have one that does. And so you have to have some kind of transaction ID and use that as the key and partition by that. That's all I got in my WhatsApp right now.
Well, thank you very much, Tim, for graciously answering all the questions, both from the audience here and from YouTube chat. Really thank you for joining us today. It was great. And thank you for the audience here and on YouTube. And thank you, everyone. Thank you, everyone, and hope to see you soon again. Thank you.
Have a great night. All right, bye.
Thank you, Tim.